Sometimes, it seems that time is just a background. That it flows somewhere nearby, not interfering, not arguing, leaving no trace. We are used to thinking about time in human scales. A year, a decade, a century, sometimes, a millennium, if we speak of stone, empire, or memory. But there is another measure. Almost incomprehensible. 65 million years. This is not a span for a single life. Not a span for a single culture. Not even a span for a single planet in the human sense. It is a depth where familiar ideas of beginning and end disappear. It is an interval where civilization does not simply develop. It has time to become something we might not even call civilization in the usual sense. It is hard to imagine precisely because we always mentally add catastrophe to history. Fire, collapse, war, ice age, system failure, chance that breaks continuity and forces everything to begin again. Our memory loves such breaks. It builds drama on them. But if there is no break, if nothing resets what has been accumulated, then the very logic of development changes. Then knowledge does not disappear with a generation. Mistakes are not erased, but become part of a long engineering memory. Cities do not just grow, they outlive their own forms, as living organisms go through stages of growth. Institutions do not dissolve but become denser. Technologies do not change by leaps, but slowly increase in complexity, layer by layer, like geological strata. And at some point, it becomes impossible to say where culture ends and infrastructure begins. Where science ends and environment begins. Where machine ends and landscape begins. Because a civilization that has 65 million years without a catastrophic reset ceases to be simply a society. It becomes a process of accumulation. It starts to think not in generations but in epochs. Not in projects but in trajectories. Not in buildings but in forms of existence of matter. It is here that the quietest, yet most important question of this reflection arises. Not what they would build, but what remains possible at all if time does not interrupt the work of reason. Because in the short term, we build what we can finish in a lifetime. In the long term, what will outlive us? But on a bottomless timescale, something else appears. Architecture that does not need a human rhythm. Engineering for which a single planet is no longer enough. Designs for which a star is not a symbol, but a source of material, energy, and form. And then civilization starts to resemble not a city and not an empire. Rather, a slowly growing system that learns to handle physics itself as an instrument. Perhaps this is what a true difference between short and long history looks like. Not in how much they have built, but in how deeply they have managed to change the very notion of building. If time does not break, if memory is not reset, if every next step stands on millions of previous ones, then the limits of the possible recede very far. So far that we are no longer sure if what we see before us is technology or a new form of nature. And if this thought seems too vast, too far from familiar experience, then the next step is very simple. Look at what happens to civilization not over a century or a millennium, but over a truly bottomless interval of time. We rarely notice that the time available to us is not just a backdrop for events. It becomes the densest currency in the history of any civilization. In human terms, 100 years is almost eternity. Dynasties change, cities vanish, habits dissolve into dust. Even 1,000 years seems beyond personal imagination. But if you try to picture not 1,000, not even 10,000, but 65 million years of continuous development, familiar markers begin to dissolve. Perhaps the strangest question hides in the most familiar one. What becomes the main limiter if catastrophes no longer break the chain? If there is no need to start again? At first glance, the answer seems simple: more time means more progress. But that is only the first layer. Time becomes not only a measure of development, but an instrument that itself can build new modes of existence. In human history, every era resembles an attempt to survive between failures. Whole cultures have disappeared, sometimes leaving only traces in soil or stone. Interruption is the familiar state. Catastrophes, wars, climate shifts have always forced us to begin from zero. We tend to see this as a given. But if you remove this factor, if time does not break but flows evenly and steadily, Accumulating not just success but also errors, something new arises. Sometimes it seems we live in a world of short engineering cycles. Something new is built, a generation passes, and everything starts anew, at a new level, but with new growing pains. Technologies grow more complex, but institutions do not always keep up. The accumulation of knowledge happens in fits and starts. But if you let the process flow uninterrupted, then even mistakes become building material. Not just successes, but failures begin to work for the future. Slowly, almost imperceptibly, civilization learns not to repeat the same dead ends, not to fall into the same traps. Time, stretched to millions of years, becomes not just a resource, but an amplifier. It allows not only to build, but to rebuild, perfect, and polish mechanisms until they begin to work automatically, without constant intervention. Engineering habits turn into traditions, traditions into institutions, and institutions into stable ecosystems of knowledge. A culture arises not of inventing individual devices, but of inventing ways to invent. Every technology that once appeared by accident becomes not the exception but the rule. Everything that can work, will work better and better. Everything that breaks will be fixed, rewritten, optimized. Not as it happens in our history, where any complex system sooner or later meets the limits of a human life, oblivion, loss of motivation. Here, time works on the side of order. On the Kardashev Scale, which was once conceived as an imaginary ladder for civilizations, human experience seems almost a barely visible point. We are only beginning to manage the energy of our planet. But if a civilization has not just thousands of years, but tens of millions, this ladder ceases to be fantasy. Every step, every rung becomes not an abstract dream, but a very real stage. At first, control over planetary energy. Then, mastery of a star's energy. After that, galactic scale. Time allows not just building, but making mistakes without fear that a mistake will be the end. Perhaps the duration of uninterrupted development is the key missing component in all our models. We are used to fragility. It seems to us that everything built can be destroyed. But if destruction never comes, if there is a chance to learn from the errors of 10, 100, 1,000 previous generations, then engineering ceases to be a craft and becomes something like biological evolution, only much faster. Everything viable survives not by accident but by design. Everything that does not work disappears, but leaves not emptiness but knowledge behind. There are things that happen so often that we stop noticing them. The accumulation of habits, automation of processes, the transformation of rare experience into the ordinary. Over millions of years, these processes do not just accumulate, they fuse into something new. Technological culture becomes not a set of unique solutions, but a self-sustaining system where any improvement becomes the basis for the next. In such a universe, engineering thought ceases to belong to just individuals or even generations. It becomes part of the environment, part of the fabric of civilization itself. A simple idea. If every next step is built on the experience of all previous ones, then the limits of the possible move not linearly but exponentially. Megastructures that on our timescale seem miraculous or fantastical become simply the next stage of development. That is why, when we look at the Kardashev scale as a ladder leading to an almost unattainable scale, it is important to remember. This ladder is built not only of energy or technology, but also of time. Time is the most reliable builder. It allows not only creating, but correcting, refining, perfecting. It turns even the most complex tasks into habitual ones, and the impossible into the repeatable. At first glance, it seems ordinary, but if you think about it, it becomes clear. Without interruptions, civilization sooner or later begins to build not individual things, but the infrastructure for endless growth. It ceases to fear chance. It begins to trust time. And then the main question is no longer what it will build, but how it will learn to build, again and again, ever faster, ever more precisely, ever larger. And when time becomes not just long, but truly deep, the first change happens not in material, and not even in energy. Above all, the very way civilization learns to build changes. Engineering becomes the environment. Everything possible becomes inevitable. Everything impossible awaits its hour. And when that hour comes, even the most unattainable goal begins to change the very logic by which engineering is possible. There are things that happen so often that we stop noticing how they become the foundation, almost a second breath of civilization. When we talk about development, we most often picture cities, roads, bridges, giant dams, power lines, satellites in orbit, factories that never sleep. But all these structures, however grand their arrival may seem, remain on the surface of the planet. They are rooted in gravity, linked to rock, water, wind, to what is mined and moved here, on this small segment of land beneath a thin atmosphere. Sometimes, it seems as if engineering itself has a ceiling. A limit beyond which everything becomes too complex, too expensive, too fragile. But if you think about it, this limit is not physical but temporal. It arises because humanity has the habit of starting over, after a war, after a catastrophe, after a reset that nullifies accumulated schemes and established rhythms. But what if there is no reset? If time flows smoothly and persistently, like a river without floods? Then engineering ceases to be a series of heroic leaps and becomes the slow, almost organic cultivation of new layers of infrastructure. The beginning always looks familiar: mining ore, redistributing resources, automation, logistics, power grids that grow and branch like the roots of a tree. But over time, a strange saturation point appears. The most valuable elements are no longer on the surface. Deposits thin out, but the need only grows. At this point, the gaze lifts above the horizon. The first stations in orbit are not yet a promise of a new era, but merely a continuation of extraction, collecting solar energy, processing waste, communication nodes that make managing the planet easier. But as time goes on, it becomes increasingly clear that orbit is no longer just a transport corridor. It turns into a new territory where engineering of a different kind is possible. On the planet's surface, everything is bound to weight, to friction, to erosion, to the unpredictability of the atmosphere. Every structure is forced to fight against collapse, destruction, the fatigue of metal. But in orbit, resistance almost disappears. Here, one can build delicate, branching, mobile forms. It's easy to move cargo, combine materials, create shapes impossible in gravity. Gradually, new experience accumulates. Automated factories learn to assemble themselves, first from parts brought from the surface, then from asteroid material, then from lunar rock and comet ice. Time is no longer an enemy, but an ally. Each iteration leaves behind not a museum, but a working prototype that becomes part of the next chain. Orbital stations grow in size, turning into hubs for processing, manufacturing, storing energy. Solar panels, once seen as a luxury, now line up in giant grids spanning thousands of kilometers in orbit. Swarms of mirrors appear, concentrators, collectors of various configurations, all for the sake of not only gathering, but directing energy where it is needed most. At this stage, it becomes clear: a planet is not the only stage for engineering. Now it is possible to build where there is no soil, no atmosphere, no familiar foundation. A new infrastructure is growing, not on the surface but around it. The logic shifts. Instead of a single center, there are many points, connected by light, by radio waves, by streams of control. And then, one day, after thousands, perhaps millions of years, the orbit begins to resemble not just a service zone, but an independent ecosystem. Every satellite, every factory, every solar module is a cell of a single organism. They interact, adjust each other's trajectories, recycle waste, redirect energy, renew parts. There is no place for chance here. Mistakes are healed in many ways, from replacing a module to a complete rearrangement of a node. Slowly, layer by layer, this orbital organism grows. At some point, its mass and complexity become comparable to small moons. Engineering no longer counts in kilometers, but operates in tens of thousands of tons, in millions of square meters of surface, always turned toward the light. Humans, perhaps, are no longer the chief architects. More and more, the functions of design and control pass to automatic systems that know no fatigue or sleep. Then a new image emerges, one that was once just a hypothesis: a swarm around a star. Not a sphere, not a rigid structure, but but a cloud of billions of autonomous modules gathering, reprocessing, redirecting energy right at the source. This is not the decor of science fiction, but the logical result of long, unbroken growth. There is no sharp transition. Each next step is just a little farther, a little more complex, a little bolder than the last. First, panels around the planet, then, stations on various orbits, then, energy collected from asteroids. And finally, the entire stellar system becomes the stage for engineering. Perhaps this is what a mature civilization looks like, one untroubled by catastrophe. Orbits become not empty space, but infrastructure capable of turning the light of a star, maybe even all of it, into controlled, directed energy. The most ambitious projects are no longer limited by a planet's surface. They rise to a level of architecture where the main goal is not simply survival, but managing the flows of matter and light on the scale of an entire sun. There is a sense that this is not a miracle, not a leap, not fantasy invading physics. It is simply another floor, another level of the same process that began with the first mine or the first generator. Time, unbroken even for a moment, makes the impossible possible, the abstract real. But as soon as civilization moves beyond its planet, it becomes clear. The main limit is no longer resources, but the ability to manage complexity. We seldom notice that complexity itself is not just the sum of its parts. It starts to behave as a phenomenon in its own right, with its own laws, its own rhythm, its own logic. Like water slowly filling a cup until it becomes a sea, whose surface lives by the laws of waves, not droplets. In the usual story of civilizations, complexity rarely reaches the threshold where familiar methods of control vanish. Empires collapse under the weight of unsolvable problems, cities degrade through the inability to coordinate growth, even a simple road network descends into chaos without precise coordination. But if you remove collapse, remove catastrophe, give time a steady, uninterrupted flow, a turning point comes when familiar tools cease to work. At first, it seems that to manage orbital rings, solar power stations, and fleets of automated factories, it is enough to simply complicate old methods. Add more layers of management, refine protocols, divide tasks among thousands of coordination centers. But with every new turn of the system's growth, something strange happens. There is a sense that the fabric of the task itself is no longer subject to human control. At scales where construction covers millions of kilometers and synchronization demands a precision beyond human imagination, the old ways of management are not just inefficient, they become impossible. A new measure of complexity arises. Not where individual elements require control, but where the network itself, the motion itself, the resource flows themselves become phenomena beyond individual understanding. Sometimes it seems that here, at this threshold, the necessity for a new mind is born. Not in the sense of creating a better assistant for humans, not in the sense of speeding up or automating routine, but in the sense of a layer that becomes the very medium within which and for which such construction is possible. Artificial intelligence here is not a threat and not a rival. Rather, it is a way to keep in focus a process that would otherwise fall apart under its own weight. In a civilization where engineering tasks go beyond the planet, AI becomes not a tool, but a nervous system. It designs, coordinates, repairs, learns from mistakes, finds optimal solutions where the human mind simply cannot keep up with events. One can imagine quiet management, millions of autonomous construction drones scattered across orbits, synchronized not by commands from Earth, but by a complex, self-adjusting network. Each one is a node, knowing only its local task, but together they form a single structure that builds itself, maintains itself, and perhaps even heals itself if something goes wrong. In such a system, humans are the source of goals, but not the operators. Decisions made on millisecond scales, requiring analysis of trillions of parameters, cannot be delegated to individual minds. AI becomes the mediator between the intent of civilization and its physical embodiment in matter, energy, and space. Perhaps the strangest thing here is not the replacement of human by machine, but the natural overflow of scale, where intelligence is no longer a property of a living being, but of the environment itself. As if the very space between orbital stations gained the ability to think, to plan, to correct. There are things that happen so often we stop noticing them: automation, delegation, the creation of ever more complex protocols. But give this process millions of years, and it ceases to be just a technical solution. It becomes a new form of collective existence. When the design of megastructures becomes not a one-time action, but a constant, unbroken evolution, maintained by self-learning, self-tuning systems. Sometimes it seems as if this perspective is frightening. But if you look without emotion, it becomes clear. At a certain level of complexity, there is simply no other way. Not because someone wants to replace humans, but because the very measure of the task changes. Just as neurons and nerves appear in an organism when body size exceeds the point where simple diffusion can no longer coordinate, so too does civilization acquire a layer that takes on the functions of management and correction. You can argue over the details, whether such an AI will be centralized or distributed, whether it will retain traces of human logic or become something entirely other. But its necessity is dictated not by will or design, but by the inevitable mathematics of complexity. At this level, engineering stops being merely the construction of objects. It becomes the creation of an environment in which objects build themselves. Where, over millions of years, a megastructure resembles an ecosystem more than a building. It is born, it grows, it rebuilds, adapts, changes shape depending on external and internal conditions. Perhaps such AI is not the end of history, but its continuation at a new level. It is not separate from civilization. It is the nervous system binding together billions of devices, flows of energy and information. And if you look from far enough away, you can see how the star itself becomes part of this system. Its light, its heat, its magnetic fields, all included in a cycle, managed, maintained, synchronized by new intelligence. And then megastructures cease to be merely gigantic objects. They become manifestations of maturity, where the boundary between technology and nature blurs. Where AI is the infrastructure, and infrastructure is the mode of existence for civilization on scales that once seemed impossible. Crossing this threshold, we find ourselves before a new question. If all this is possible, if millions of years provide not only mass and time but an entirely new nervous system, what form will this maturity take? What shape might a civilization have for which a star is not a limit, but just one building block? Against this background, a megastructure is not a matter of fantasy, but a matter of form and maturity. There are things that, from a distance, seem almost impossible. A sphere around a star, an idea that sounds like a fairy tale, a strange metaphor more at home in stories and dreams than in blueprints. At first glance, the very thought that one could not merely observe starlight but enclose it, capture every grain of energy, seems almost sacrilegious. We are accustomed to the scale of a planet. Anything larger feels unimaginable, beyond real embodiment. But if you look closely, it becomes clear. For a civilization with tens of millions of years and no catastrophe to steal its time, these constructions are not wild fantasy, but a mature, natural stage of development. It is not ornament, not arbitrary ambition. It is logic, brought to the limit. As soon as it becomes possible to control matter at the atomic level, as soon as technology appears that can work in a vacuum, as soon as AI becomes the nervous system of distributed processes, a new question arises. How not just to live near a star, but to live by its very nature? The Dyson Sphere, and all its variations, from solid shells to swarms of billions of separate stations, is not an attempt to block out the sun, but a way to master the most basic energy a star gives. First come orbital panels, separate satellites, then, cohesive swarms coordinated by a network of artificial intelligence. With each turn of technological maturity, the boundary of the possible recedes. A construction that seems madness to a young world, after millions of years, becomes just another kind of infrastructure. Perhaps the most interesting thing here is not the form, but the very logic of transition. For a civilization that has traveled the path from first tools to atomic control, there are no fundamentally new miracles, only new scales. At some point, the task becomes not so much to build something enormous as to learn to maintain stability, balance, coherence among billions of elements in a complex dance around a star. A Dyson swarm is not a solid shell but a cloud, where every element is autonomous yet networked. This is architecture with no central wall, but the whole system lives by the rules of distributed intelligence. We rarely consider that, for such a civilization, the concept of a building, structure, machine begins to blur. When engineering leaves the planet, the familiar words lose meaning. There are no facades, no rooms, no usual scale. There are dynamic structures, changing shape, density, even composition, according to needs and intentions. A Dyson sphere is not a shell, but a process. Continuously renewed, self-adjusting, almost like a living organism. If we could look inside such a swarm, we would not see a solid wall, but an endless network of stations, mirrors, collectors, laboratories, storage, transport channels. All of this works on different orbits, in differing rhythms, but is bound in a single system of energy, information, and resource exchange. From the outside, it may look like an unstable, chaotic construct. But from within, like a perfect ecosystem, where every element knows its place. Here, engineering maturity is shown not in the size of the structure, but in the ability to balance billions of complex chains, to foresee and correct fluctuations, to maintain balance between order and chaos. Perhaps the quietest thing that can be said about such megastructures is, they cease to be special. Just as, once, electricity for life on Earth ceased to be magic and became a utilitarian part of the landscape, so too, for a long-lived civilization, a swarm around a star becomes simply a habitat. There is no desire to astonish, no striving for grandeur for its own sake. There is only development, which ceases to be linear and becomes almost organic. Megastructures are no longer a finale. They are only the beginning of the next stage, where a star's energy becomes as mundane as breath for a living organism. Sometimes, it seems that what unsettles us is not the scale itself, but how it blurs the line between technology and nature. The Dyson sphere is not a part of civilization, but its continuation, almost like a second skin. It is less a structure than a state of matter, in which civilization ceases to be a guest of its star and becomes part of its inner dynamics. And if someone were to observe such a swarm from afar, perhaps they would not immediately realize it was the product of intelligence. Everything appears too orderly, too deeply inscribed into the rhythms and laws of the star itself. As if engineering maturity has crossed into that realm where it merges with physics, where the artificial is no longer clearly distinct from the natural. At such scales, civilization becomes part of the astronomical landscape. It does not build, it grows into the very substance of space, weaving itself into the flows of light and matter. Perhaps the strangest question hides in the most familiar one. If we saw such a structure, would we even recognize it as artificial? Or would it seem to us just another law of nature, another form we do not know, but which for someone else might be part of everyday life, part of ordinary routine? Megastructures that have lasted millions of years become not only engineering objects, but a new language for the universe itself. But the further time stretches, the less familiar measure matches familiar form. Sometimes, it seems that the very idea of architecture is limited by familiar shapes. We think of houses, towers, bridges. Even the boldest of them remain within what can be built by hand, what obeys earthly scale. But from the vantage of millions of years, a strange feeling arises. Familiar categories cease to function. Time stops being merely a backdrop. It becomes an instrument, able to change not only matter, but our very notion of what is possible. We rarely notice that the difference between nature and technology is always a question of scale and habit. Rivers and mountains seem natural, because they were shaped not by a hand, but by the impersonal motion of time. But if we imagine a civilization for whom millions of years are not a limit, but a working unit, then its creations too begin to seem part of the landscape, not exceptions from it. At first glance, it looks like distant fantasy. Megastructures encircling entire stars, swarms stretching for billions of kilometers, networks threading the sky. But if engineering is given enough time, it ceases to be a project. Its forms grow so vast that they merge with the very physics of space. At some point, the difference between what is built and what exists disappears. Perhaps the strangest question hides in the most familiar one. Where does technology end and cosmology begin? What happens when a project doesn't last a century, but a million years? When matter, energy, information, and time become interchangeable tools, and the boundaries between them, fluid conventions. Some things happen so often that we overlook their philosophical depth. For example, how our view of space changes if it can be transformed as easily as we rebuild cities. For us, emptiness is simply a backdrop where events unfold. For a civilization with millions of years of engineering maturity, emptiness is material itself. Something to weave structures from, to carve windows into, to create new forms of existence. We can imagine that at some moment, geometry itself becomes the language of creation. Not separate objects, but entire regions of space, woven according to laws that were once discoveries and are now routine. The engineer becomes not a builder, but a cartographer of new physical realities, where familiar limitations give way to the possibility of rewriting the very conditions of being. Perhaps then engineering passes to a new level. From a set of concrete solutions, it becomes part of the background, part of the very fabric of the cosmos. As if a mature civilization does not construct objects, but weaves itself into the laws that surround it. As if its traces are not visible to the eye, but emerge in the curves of space, in hidden symmetries, in patterns that seem part of nature but, in truth, are the result of a long, almost silent labor of mind. In such moments, our usual measure of the possible begins to drift. We are used to thinking that matter and space obey fixed laws, that anything exceeding human scale cannot be the work of hands. But if history isn't interrupted by catastrophe, if time becomes an ally rather than an enemy, then even the laws themselves may not be a boundary, but a starting point for the next step. Can we distinguish an ancient megastructure from a natural phenomenon, if it is so vast and stable that its traces blend with the laws of physics? Perhaps, at some point, the universe itself comes to seem like compressed history of such projects, so ancient that no one remembers their original intent. Only geometries remain, looking like part of matter itself, but in reality, they were once choices, acts of will, decisions. In this context, the usual